town. And part of the ecosystem is a Catalyst Space Accelerator. And right now we have a cohort going through the program. Focused on positioning, navigation, and timing technologies, so GPS alternatives. So we have anything from Cold Quanta with their quantum physics clock to teams that are making PNT technology for drones, ground vehicles, autonomous ground vehicles that potentially the Army could use, and then also some Navy and special operations use cases for their technologies. So this idea, the accelerator elevator, or pitch elevator, derived from one of our program managers from the Air Force Research Lab, Captain Jake Singleton. I call him Captain America. And so he's in charge of all the accelerator programs right now for the Air Force Research Lab. You'll meet his counterpart, Lieutenant Zoe Castile, tomorrow. She'll be speaking on a panel. So we did this at the Space Symposium that Shelley spoke about earlier today at lunch, where we had companies come up to the AFRL booth and give us a 2-3 minute pitch and to see what kind of ideas they had. And so they were also encouraged to, after they pitch, apply to some AFRL SIBRs. So that's kind of how they got some ideas. So we'll kick this off with our very first company, AMPT, Advanced Mobile Propulsion Test in Agile Space.
We're really going to boot them at performances. And this is hard to do.
How's it going, y'all? I'm Julian Miller, CEO of Agile Propulsion, or Agile Space Propulsion, actually. And I want to tell you guys a little bit of a story today. And if you guys don't know who this guy is, it's W. And upon W's first term in office, W deemed it critical that we would have, as a United States of America, a ground-based missile defense system. And part of that missile defense system was this exo-atmospheric kill vehicle. Now, when all was said and done, this project took over 15 years and $40 billion worth of taxpayer resources. Now, that's over 3 presidential terms when this was deemed as mission critical for national security. So what was really the or really the reason for all these delays and the cost? Well, newsflash, rocket science is hard, and the propulsion systems on the EKV were one of the longest lead time items and one of the most difficult pieces for them to actually get through and flight qualified. So it actually took 5 years of design and development to actually get a system ready to be qualified and tested, and then another 1.5 years of actually refining and iterating and figuring out why it was failing. So I actually had to water down that design in the end product that actually went up and was successful after 15 years. So that whole process, we actually are really intimate as AMPT and Agile, which we actually spun out of AMPT. And the reason why, if you guys aren't familiar with AMPT, we're based down in Durango, and we test in-space propulsion systems. We've got over 3,000 hot fire tests under our belt, including a lot of the systems going on here. So Dowdy, our founder, is actually very intimate with why these systems failed. And a lot of, along that process, he kept thinking, there has to be a better way to do this. So if I can get a clicker, slide forward. Awesome. So basically, the way we have solved this problem is by leveraging lean startup principles in terms of rapid prototyping and iteration, as well as lean design principles. So what we're able to do is actually leverage 3D printing and additive manufacturing in order to actually close that gap of iteration cycles and actually really speed things up by also pairing that with our testing facility, which is very state-of-the-art in the context of in-space propulsion systems. So what we've actually started doing now is developing propulsion systems using additive manufacturing. One of the first systems we took to TRL 4 and 5, basically 9 weeks time. So that's weeks, not months, not years. That's completely changing this paradigm of what it takes to develop and qualify space propulsion systems. So by using these techniques, we can really close this gap and actually accelerate the pathline to market, but also eliminate a lot of the headaches that are encountered along the way in developing these systems. So basically, at the end of the day, we're here to hopefully forward the market. Right now, we're developing both 100-pound and 5-pound thruster systems, but we have the capacity to locally optimize based on any design anywhere between 1 pound of thrust and 1,000 pounds of thrust. And we have these capabilities down in Durango. We're here local in Colorado. We're, just great steward of the industry, and we're here to help. So at the end of the day, if you guys have any propulsion needs, feel free to reach out to us. We really are working to make moonshots possible and other highly difficult project-specific, say, applications where you have really tight timelines. you have really aggressive cost constraints, or you have really high performance specifications like what existed on the EKV. So again, feel free to reach out if you guys have any propulsion needs or want to learn a little bit more about just additive manufacturing in general.
Is interested in learning more about the Catalyst Space Accelerator, our program director, Kamar Gartman, is right here in front. She can answer any questions that you may have about the program. And we plan to do about 2 cohorts, I believe, a year. And majority of the focus of these programs are focused on space technologies. And I believe the next one is going to be space situational awareness. So keep your eyes open for any information about the next cohort. So the second company is DeFore Innovations, LLC.
Thank you. Well, I'm an ag tech company, and we're excited to be here today. And our plants almost didn't make it. They spent 14 hours in the cooler, came from Georgia. They were packed up yesterday at 6 o'clock. But what we have is a product that helps solve some of the biggest problems in agriculture. We've got a growing population, and that population needs to be fed. We also have issues with labor cost, labor shortages, food safety, food security. We waste almost 1/3 of all food produced. So there needs to be some solutions. And what we've come up with is a hydroponic sleeve. It's a vertical sleeve that's cut to length. It's a one-time use product. It can be pre-seeded during the manufacturing process. Currently it's made out of plastic that's recyclable, but we have some prototypes over there that are compostable. So we look to eventually have the entire product being compostable. So our ultimate vision of the product is that it will be fully automated from seed to harvest. Think of this as a printer cartridge, but for growing plants. So you'll put it in the system, it'll grow it from seed all the way to harvest, and you'll never have a human hand touch it. Currently, we're in the research and development phase of the product, and we are seeking funding. We have several systems growing, as you can see, and we've got several partners that we've been working with. We applied for an STTR grant this past fall. We got some very positive feedback. We didn't get that, but we got some very positive feedback, and we're encouraged to apply again this next year. One of the reviews said that it had large potential for commercial application. There's 52 billion square feet of indoor growing space. The majority of that is outside the United States. So there's potential for a large growth here in the United States. So we're looking to move the product forward. You can go ahead. I'm sorry. You can change it. Yes. And you can see it could grow some very large plants, and it produces a really nice root system. I'm sorry. Go ahead. Yes. But go ahead and get in touch with us if you have any questions. You can follow us on GrowMesh on Instagram or DeForeInnovations.com. Thank you.